By the end of this video, we want to be able to say that I can solve real-world optimization problems using linear programming. Just as a quick reminder, linear programming is a method for finding the maximum or minimum values of a function over a given system of inequalities, with each inequality representing a constraint. In this example, we know that a school club is selling notebooks and pencils to raise money. Each notebook costs $3 to make, and each pencil costs $1 to make. The club has a total budget of $30 for supplies. They must make at least 2 notebooks, and they make at most 9 pencils. Each notebook earns a $5 profit, and each pencil earns a $2 profit. Write a system of inequalities to represent the constraints, graph the feasible region, and determine how many notebooks and pencils the club should sell to maximize their total profit. The first thing we are going to do is write the system of inequalities. We know that each notebook costs $3, and we know that each pencil costs $1 to make. So let's call the notebook our x value, and let's call the pencil our y value, so that this will be 3x add to the value of 1y. And we know that our budget is $30, so we cannot spend more than that. So this would be less than or equal to $30. We also know that we must make at least 2 notebooks. This means that our x value has to be greater than or equal to 2. The other thing that we know is that we must make at most 9 pencils, so we cannot make any more than that. By the way, we cannot make a negative amount of pencils, so this would be 0 is less than or equal to our y value, which is less than or equal to 9 pencils. The very last thing is our function to be able to maximize the profit. We know that each notebook can earn $5 as a profit, and each pencil can earn $2 as a profit. So in other words, our profit function, the f of x comma y, is going to equal 5x plus 2y. So this is our system of inequalities. The next thing that we need to do is graph the feasible region. Notice our graph, we only have positive values. This is because we cannot make a negative amount of pencils or a negative amount of notebooks. So to graph this, let's go ahead and make ourselves a table for the x and y values. So let's choose our y value to be 0. If y were to be 0, then we end up with 10 being our x values. So we would have 10 notebooks with 0 pencils being made. Let's also choose our y value to be 3. If y were 3, meaning 3 pencils being made, then we will end up with the grand total of 9 notebooks. So this graph would look like this. In order to know which side to shade, let's just choose a point. Let's choose 0, 0. With 0, 0, we would end up with 0 less than or equal to 30. Well, because that is true, we shade towards 0, 0. To graph the inequality of x is bigger than or equal to 2, we know that this would be a vertical line because there's no y values. So we have a vertical line at 2. In order to know which side to shade, all we had to do is just look for a value that's bigger than or equal to 2. A value that's bigger than 2 is 4, another value is 6, and so on. So we shade towards 4 or 6 or 8 or 10 or any other value that's bigger than 2. If you want to graph the inequality of y being between 0 and 9, we notice there's no x values, so this is 2 horizontal lines, one being at 0 and another being at 9. If we want to shade this one, we know that y is stuck between those values, so we just shade between these 2 values. So we see the following is our feasible region. The next thing that we need to do is determine how many notebooks and pencils the club should sell to maximize their total profit. If we want to do this, we have to know what our vertices are. As we notice, we have a vertice at 2, 0. We have another one at 2, 9. We have another one at 7, 9. And our last one is at 10, 0. So to figure out the maximum total profit, we just substitute each of these order pairs into our function. Doing this, we will see that f of 2, 9 is going to give us 5 times 2 plus 2 times 9, which is 10 plus 18, which gives us 28. If we do f of 2, 0, this is going to be 5 times 2 plus 2 times 0, which is going to give us 10. That's not maximum. That's smaller than that value. If we want to do f of 10, 0, this is going to end up to be 5 times 10 plus 0, which gives us 50. And lastly, if we want to do f of 7, 9, This would give us 5 times 7 plus 2 times 9, which gives us 35 plus 18, and that equals 53. The largest is 53, so our maximum total profit is $53. In this example, we're told that the van of a florist can carry up to 50 pounds and has a space limit of 10 cubic feet. Each order must include at least one of each type of plant. We have a fern and we have an orchid. The weight of the fern is 5 pounds and its volume takes up 2 cubic feet, and the profit is $6. With the orchid, we have the weight being 8 pounds, the cubic feet is 4 cubic feet, and the plant profit is $9 per plant. We want to write the constraints if each plant has its maximum weight and volume. In order to do this, let's take first the weight. We know that the van can carry up to 50 pounds. So doing this, we have 50 pounds is the maximum weight that we can have. And we know that the fern is 5 pounds. Let's call that 5x. And the orchid is 8y. The next thing, we know that we have a limit on our cubic feet, the space that we have in the van. So we know that 10 is our maximum on that. So doing this, we have 2 times the fern, which is our x value, plus 4 times the y value, which is the orchid. The last thing we know for our constraints is that we must include at least one of each type of plant. So we must sell at least one fern and one orchid. So doing this, we would know that x has to be bigger than or equal to 1, and y is bigger than or equal to 1. So this represents our system of inequalities. The next thing is that we want to write a function to represent our profit. We know that f of x comma y will be our function, and we know that our profit is going to be 6 times our fern, and we know that our profit will end up to be 6 times how many ferns we sell, plus 9 times how many orchids we sell. So our function to represent the profit is f of x comma y equals to 6x plus 9y. If we want to graph this, let's go ahead and start by making our table for our x's and y's. We're going to start off with our red inequality. If we choose x to be 10, we would end up with 50 plus 8y less than or equal to 50. Subtract by 50, we end up with 8y less than or equal to 0, so y is less than or equal to 0. So in other words, y will be 0 in this case. Let's go ahead and choose another random point. The next value that we're going to choose is x equals 2. If x were 2, we end up with 10 plus 8y less than or equal to 50. Subtract by 10, we end up with 8y is less than or equal to 40. Divide by 8, so y is less than or equal to 5. So in other words, for our boundary's sake, y is going to be 5. So our graph would look like this. Also notice with our graph, we can only have positive values. This is because we cannot sell a negative amount of plants. If we want to figure out which side to shade, let's go ahead and just plug in 0, 0. So plug in 0, 0, we would end up with 0 is less than or equal to 50. That's true, so we shade towards 0, 0. Doing the other inequality, we are going to make a table as well. Let's go ahead and choose our x value to be 1. If x is 1, we end up with 2 plus 4y less than or equal to 10. Minus by 2, we end up with 4y less than or equal to 8. Divide by 4, so y is less than or equal to 2. So in other words, for our boundary's sake, y is 2. If we choose our x value to be 3, we can end up with 6 plus 4y less than or equal to 10. Minus by 6, so 4y is less than or equal to 4. So y will be 1. Graphing this, we end up with the following. Figuring out which side to shade, let's go ahead and choose the same point, 0, 0. 0 is less than or equal to 10, so we shade towards 0. Graphing x is greater than or equal to 1, that's going to be a vertical line at 1. We know x is bigger than that, so choose a value bigger than that and shade towards that value. Graphing y is bigger than or equal to 1, we are going to have a horizontal line at 1. Shading this, pick a value that's bigger than y. We know that 4 is bigger than y, so shade towards 4. So the feasible region for this system of inequality is this. If we want to determine these vertices, let's just look at the graph. We have one at 1, 1, 1, 2, and another one at 3, 1. So we have determined the feasible region and determine the vertices. The last thing that we want to do is to determine the number of each type of plant to maximize the profit. I'm going to take our profit equation that we have up here, and I'm going to rewrite it. Doing the function for each of these vertices, we end up with f of 3 comma 1 equaling 6 times 3 plus 9 times 1, which is going to be 18 plus 9, which gives us 27. Doing f of 1 comma 1, we end up with 6 times 1 plus 9 times 1, which gives us 6 plus 9, which gives us 15. And lastly, if we do f of 1 comma 2, we notice that we have 6 times 1 plus 9 times 2, which equals 6 plus 18, and that gives us 24. So what is our maximum profit? 27.